Cape Talk, the world of science with Dr. Chris Smith, the naked scientist.
Welcome back, Chris, to Upfront with Refilwe. How are you?
I'm really good, thank you very much. All the better for talking to you this fine Friday.
Indeed. How was your time away?
I was involved at Murdoch University in Perth, where I go because I've got a visiting professorship there. And a lot of South Africans in Perth. It's quite funny. You go and do a talk or a show, loads of people come up and they say, hey, listen to you on 702 and Cape Talk and so on. So it's really nice, actually. But I was there because they're going to set up something called the Australian Phenome Centre. And this is going to open at the beginning of October. They've spent a long time sorting this out, and it's a very big budget project. But it's really going to revolutionise, I think, the way we do healthcare in future, because they're going to start collecting samples from very large numbers of people, putting these samples into analysers, and these could be blood samples, urine samples, even samples of your breath. They'll be able to pick out, with the very, very powerful machinery they have, hundreds of different molecules which are present in all these samples, and not just identify that they're there, but identify how much of them is there in each of the samples. And what this will enable them to do is to build up almost like a biochemical fingerprint of the way your body is working. And if you do this on enough people, enough times throughout their life course, you can begin to formulate what should be a healthy spectrum of these molecules, both for a population but also for the individual. And you can use that to predict who is going to get what disease in 20 years' time unless they make changes to their life. So you could, for example, say you did the genome on somebody. You could find a gene that someone's carrying and it might say they're going to die of, say, alcoholic cirrhosis. Well, that's only useful if that person ever drinks alcohol. And you've no way of knowing from their genome what their environment's like. Whereas if you do their phenome, this tells you immediately whether or not this person with this risk is exposed to the very thing that's going to be a problem for them. And so you can then give them lifestyle advice or other guidance. This is just starting now, but it's going to be really powerful and really exciting. And I think the ultimate point is it will shrink down to a tiny box in a doctor's surgery. So when you go to the doctor, rather than take various other measurements, wait days for tests to come back, etc., you'll be able to do very fast, predictive tests very, very accurately and say to people, right, these following things are a bit off whack in you. You need to change the following things, come back in a week and we'll reassess. It'll be very, very powerful, but it's going to take a while to get there. But this is exciting times for how we're going to do not just human medicine, but all kinds of science, because they're not just talking about taking measurements from people, they're talking about taking measurements from the farm animals and even the farm land that the animals and the crops are growing on in order to do the same sort of thing. And we can make a healthier planet this way and make more optimal use of the resources we have. Very exciting.
Brilliant. Yeah, there's so much information out there. May we be smart enough to actually use it and not be denialists. Barney in St. Helena Bay.
Hello, Chris. I wonder, could you tell me how close we are to producing energy from magnetic technology and then moving away from fossil energy or fossil fuels?
Good morning, Barney. The whole point about energy, yes, we need a lot of it. The world population is rising and our use of technology is rising, and the third world population embracing energy-hungry technology is rising. Therefore, we face something of an energy crisis in future, and we can't carry on going business as usual, generating electricity with a huge carbon footprint for obvious reasons. So what are we going to do instead? Well, we need some alternatives. Now, the alternatives that people are currently exploring are things like wind power, like solar power, tidal power, water power, and more efficient technology. And when I say more efficiency, we've seen a revolution in lighting. Light bulbs account for maybe 20-30% of the electricity used around the world. We're now using LED lighting, which is halving or more the energy footprint of just lighting things up. But in terms of ways that we can also generate electricity, scientists have always got their eyes open for opportunities. And I met one scientist earlier this year who's got a very interesting project flying kites to generate electricity from winds at very high altitudes. But I've not heard of anyone using magnets other than in an alternator or a generator, because a magnet creates a magnetic field. It's not some kind of perpetual motion machine generating free energy. You only get energy when you make a magnet move and induce a current in a wire, and that's what a generator does. So people are not so much interested in trying to do exciting pie-in-the-sky perpetual motion machines. They want a sustainable solution and one that we know we can easily realise and do it soon, because otherwise we can have a big problem.
Thanks so much for your question, Barney. Hassie in Grassy Park, good morning.
Good morning. A person who has cancer, when they receive chemotherapy, they tend to lose hair on their head. why do they not lose hair on other parts of their body?
Good morning. Well, actually, the answer is that they do. And the reason for this side effect of hair loss is because the way chemotherapy drugs traditionally work, and actually we're into a new regime with cancer therapies now, with much more targeted therapies where people are designing drugs that actually interact on specifically the cancer cells that are causing the problem. So many of these side effects are being minimised, although it's not perfect yet. But the way traditional chemotherapy drugs work is that they target rapidly dividing cells, because one of the things that cancers do is they grow out of control. They tend to grow in all kinds of directions without any recourse to the local laws. It's a bit like cars driving on the wrong side of the road and too fast down the highway and not obeying the speed limit. And these cells do this without they just do it with abandon. So the drugs that we've been using in the past to treat cancers target cells that grow very fast, because by and large, the cells that tend to, on average, be doing that more often than not in the body are the bad ones, cancer cells. But there are some other tissues in the body that also need a very rapid cell replacement for various reasons. For instance, take your mouth or your intestines. You are continuously rubbing away huge numbers of cells every time you eat your lunch. And when that lunch goes down your food pipe, your gullet, or into your intestine, it's going through you like an abrasive scouring pad and taking off tissue. And you need to replace that. Also, every time you put your shoes on and off, you're rubbing off thousands and thousands of skin cells. Every time you pick something up off a table, you're rubbing skin cells off your hands. You need to be able to replace these cells rapidly. So your skin grows very fast. Your hair also is made from rings of stem cells called hair follicles that produce this filament of keratin. They have a high metabolic rate, they turn over very quickly. So these drugs inadvertently hit those rapidly dividing cells and they knock them out, or at least they knock them out temporarily. Luckily, because there are in these cell populations cells that are not turned on all the time, there are cells in there that are quiescent, they're sleeping or dormant, and they go through cycles of activity. When you take the drugs away again, those dormant sleeping cells come back to life and repopulate the tissue, and you go back to normal. But at the time, that's why you get these side effects, and that's why they're so unpleasant. And it's an unfortunate consequence that you end up doing a bit of friendly fire damage in order to take down the bad guys.
Thank you. Very thorough answer there. Paul in Durbanville, good morning.
Yeah, hi. Okay, so if I put on a pair of prismodal glasses that make me see upside down, will my brain adjust like it does and make me eventually see the right way up? And then when I take those glasses off, will I actually just naturally see upside down and have to wait for the adjustment again?
Hi, Paul. Well,
that's a bit of an odd question.
The weird thing here is you're already seeing upside down and back to front, because the way in which your eyes work, the light is coming in from outside. If you imagine a ray of light, it's coming in, it's being focused and passing through your pupil, which means it's going through that central point, and then it's hitting the bottom of your retina off to the side, on the opposite side to where the light is. So everything that I'm seeing in the world is being presented to me back to front and upside down. And the retina then sends those signals to the back of my head, where the occipital lobe of my brain contains populations of nerve cells that sort this out and then present the final image to my consciousness. And because I'm used to living in a world that is naturally upside down for me, it feels perfectly natural to do that. And all of my movements are wired up so that when I see something in a certain relation to me, I respond to it by moving in a certain direction. Now, if you wear prismatic glasses which shift everything off to one side, or another kind of glasses which invert everything, then initially everything is very weird and people cannot cope. And if you put these glasses onto people, they reach for things in all the wrong places, they move in all the wrong direction. But after a while, you adapt and you get used to it, and quite quickly the world looks normal to you and you are used to interacting with this upside down world. It's not that the brain has suddenly turned everything upside down, it's that you have adapted to respond and to operate within that environment. When you then take the goggles off, everything's the wrong way again, and you feel very strange for a period of time while your brain reacclimatizes and readapts. And the speed with which you can do that, usually it goes with age. So younger people are able to adapt to this faster than older people for various reasons. And the thing that's doing a lot of these adaptations is the bit of brain at the back of your head called the cerebellum, which is a fist-sized brain region sitting below the main part of your brain at the back. And this is where you coordinate precise fine movements, speech, and that kind of thing. And the cerebellum is involved in learning new patterns of motor movements to correct for things when they don't play out the way you had expected. So if, for instance, I reach to pick up a glass and I miss the glass, the brain knows what movement it wanted to make, it knows what movement I made wrong, and the cerebellum corrects for that. So the next time the message goes through, it applies a corrective signal to put your hand in the right place to pick up the glass, not the wrong place. And that's how you correct for things like prismatic shift of vision or inversion of your world. But certainly you'll feel like you're operating okay in that environment. But when you take the lenses and the glasses off, you'll feel weird again for a while until you readapt. But certainly you'll still be aware of the fact that the world's upside down. You're just adapted to it.
Cape Talk, the world of science with Dr. Chris Smith, the Naked Scientist.
Thanks for that. Next question that we have was sent in via WhatsApp saying, is it fact or myth that putting the heater on in your car during winter to keep warm will make you sick? However, staying cool during the summer with the aircon doesn't. Isn't it the same thing?
I don't think there's any factual basis for this. It's a bit like the old wives' tale, going out with wet hair on a cold day will give you pneumonia. It's just that the kinds of viruses and bugs that make us ill tend to be more common in winter. Flu's more common in winter, therefore we're more likely to become unwell in wintertime. And the fact that the weather was cold at the same time is largely irrelevant, or the fact that your hair was wet. There is one interesting association with car air conditioning / blowers. And that is that there have been cases documented of people getting Legionnaire's disease caused by the bacterium Legionella pneumophila, and it has been linked to the blower in their car. And you might think, this is weird, what's going on here? Legionella is an environmental organism which loves damp places, and we see cases of this in people who are exposed to, for instance, the air coming out of an air conditioning unit, because that's very saturated, moisture-saturated air, which can have these bacteria in it. And people breathe in the bacteria, and it causes this chest infection. What's the link to cars? Well, it turned out that a number of people weren't putting detergents in the wash bottles in their cars. They were just putting plain water in the windscreen washer in their car. Because that sits close to the engine, it warms up and can spend a nice amount of time at high-ish temperature. And these Legionella bacteria are good at surviving up until about 50 or 60 degrees. You have to turn the water in your water tank up to 55 plus degrees to make sure they're dead. So this was creating an ideal stew pot in the engine compartment for these Legionella bacteria. And when people were washing the window, it was depositing onto the windscreen this water laden with these bacteria. And because the vent that pulls the air into the car airstream, the aircon system, is sitting at the bottom of the windscreen, the bacteria were being drawn in with the airstream and blown into the faces of the car occupants, who were then breathing them in, and there were some cases of Legionnaire's disease because of this. So there is a link to the aircon in your car, but it's nothing to do with the temperature beyond the fact that the water was at too high a temperature in the engine compartment.
Gross. This is why I like keeping the windows open. And Eric in Belleville has a question.
Yes. Hi there. The question is, if I put a piece of meat in the microwave, either to cook it and warm it up, it gets very hot on the outside first, and then the middle part of it stays cold. If I try and warm up very hard butter in the microwave, the outside stays hard and it goes soft in the middle.
Yep. And this is down to the way that microwave ovens cook food. The way a microwave oven works is that it's producing microwaves, which are a form of electromagnetic radiation. The wavelength of those microwaves, or the frequency rather, is about 2.5 gigahertz. It's making 2.5 billion of those waves every second. And that means that each of the waves, given what we know about the speed of light, each of the waves is about 12 centimetres apart. So as the waves go backwards and forwards across the inside of the microwave, the peak to trough distance is about 6 centimetres, because each wave is 12 centimetres long. And that means when you put your food in there, if it's not on a turntable, wherever the food hits the peak or trough of the waves, it's going to see a lot of energy. And when the food sees the middle of the wave, it's going to see much less energy. So you can get hot spots that will cook your cooking more in some places than others. That's why you need a turntable. There's another wrinkle here, which is that if I put the same amount of water in a microwave oven in the form of ice or in the form of liquid water, the liquid water will boil before the ice has even melted. And this is because the microwaves heat the food by making the water molecules jiggle around. The water molecules in ice can't jiggle around as much as water molecules that are free in water. Therefore, they can pick up much more energy when they're in the liquid state than in the frozen state. And this is why microwaves are really bad for defrosting food, because wherever you get a little bit of water in something where it starts to melt, it will pick up loads of energy in this region. But the more cold frozen centre, even though the microwaves can penetrate there, they can't be absorbed very well there, so it stays frozen. So you'll end up with your lamb chop or something, which is seared around the outside and still frozen in the middle. So much better to let your piece of cooking or whatever be completely thawed out before you put it into the microwave. Don't use microwaves for defrosting because they just ruin the food. It just doesn't taste very good.
I can attest to that.
Maybe it's the way you cook it. You don't.
No, I'm good at that. Staying on the cooking front, Kerry asks, hello, why does tinfoil not get hot in the oven?
Well, tinfoil does get hot in the oven, but the point about this is tinfoil is made from, not tin actually, but aluminium. It's a very thin film of aluminium, and aluminium is an excellent conductor of electricity, and therefore it's also an excellent conductor of heat, because when you've got something that's a very good conductor of heat, it's because there are lots of electrons that can wander around inside the material to carry energy, and heat propagates in exactly the same way. But if something's an excellent conductor of heat, that means that when you take it out of the oven, it very quickly conducts the heat away from itself and picks up or gives the heat to the environment. So if I have a piece of tinfoil, aluminium foil, in my oven and I heat it up, I take it out, it very quickly conducts the heat that was in it away, and as a result begins to feel cold again. The other point is it's very thin, therefore it's got very little energy actually stored in the material itself because it's so thin. Therefore it doesn't have to give much energy away before the temperature has gone down very, very dramatically. Therefore it feels like it, or it looks like it cools, because it does, it cools much more quickly. So those are the two reasons why that happens.
I love it. Why are men disproportionately affected by colour blindness, and how can it be treated, asks Margie.
Hello, Margie. The answer to this is that colour blindness is a genetic condition. One of the causes of colour blindness is carried by the X chromosome. You have in your body 23 pairs of chromosomes, and one of those pairs of chromosomes are your sex chromosomes. Those are the ones that decide if you're a boy or a girl. And if you're a girl, you have 2 X chromosomes in each of your cells. If you're a boy, you have 1 X and 1 Y. Now, if you have a genetic condition which is on the X chromosome, if you're a girl and you've got 2 X chromosomes, if one of the X chromosomes doesn't work properly, then you can compensate with the other one. If you're a boy and you've therefore only got an X and a Y chromosome, and there's a problem with one of the genes on your X chromosome, the Y chromosome is a very different shape with very different genes on it compared to the X chromosome, and therefore there isn't this capacity to compensate for the broken gene on your X chromosome. So you have to live with what you've got. And that gene for colour blindness being carried on the X chromosome means if you inherit a broken copy or a dysfunctional or a variant of that gene, then you have no way to compensate for that. Therefore, every cell in your retina that sees colour is going to be using that different form of the gene, and therefore you are going to see colours differently. Whereas a woman can have across her retina one or the other of her X chromosomes turned on, and therefore she can compensate for the gene not working. So women are still carriers of the condition, but it's not clinically manifest in the same way as it will be in a man.
Interesting. I'm just going to add that to my superior sex argument. I'm just teasing. Chris, really appreciated those insights and those answers. Very, very thorough. We already have people highlighting, especially the cold weather ones, and catching your cold answers for their parents. So thanks again for joining us.
It's a pleasure.
On Upfront with Refilwe. All right, have a good one. That's Chris Smith, our naked scientist, who's here, of course, every Friday at 9:30. Always have your questions ready.